All right. Hello, everybody. I'm back with another live coding for Uno platform. And this time I'm getting back to the thing we started last time, which is the Power Manager on WebAssembly. I also planned another thing, which was Android implementation screen capture disabling, but I noticed that's already actually implemented. And interestingly, I found out that I implemented it, so yeah, I'm forgetting stuff already. But yeah, we can focus on the Power Manager for now and maybe then start something else in parallel. So let's open up Visual Studio, and I actually will go back to the roots, so to speak, and I will check what we managed to do last time, because I don't really remember that, and also we'll check the docs on power management in WebAssembly, because I think that the specification has been updated since the last time, so it's gonna be only beneficial. So let's see. If it was battery manager, yes. So battery status API. Let's do it like this. But we want to see the spec directly, which is this one. All right, so the first problematic thing that we encountered last time is that the battery manager on JavaScript is a asynchronous interface. So to actually get the battery readings, you have to call it asynchronously, which is something that doesn't have to happen in case of UWP. So we'll have to play around with it and make some adjustments, because currently our code is just working around it by not returning proper values until the initialization completes. So we will try to find some better solution. Okay, let's wait for this one. Okay, so this is our main class. Yeah, we actually, last time we uncommented a lot of things here, so we'll have to bring them back, because we will be slowly implementing all of these. Okay, so something like this. We have energy saver status, power supply status, and battery status. So let's check what the actual interface in the browser can offer. So we have events on charging change, so when someone connects and disconnects the charging cable, charging time change, when the time for full charge changes, discharging time, how long can the device stay without charging, and the level change, not sure what that is, level. So that's probably just a percentage, the percentage changing. Well, we can actually search for the level. So that's this thing, but time. So yeah. Okay, so it's basically percentage of charging, and yeah, that makes sense. All right, so we can implement basically all of these in some manner, but what we will not be able to implement is the energy saver. I'm not sure really how do we implement it on the other platforms, but energy saver status. What does it actually mean? Energy saver. So it's basically like some API that tells you if energy is being saved. Like that's the mode that starts up when your battery is being depleted slowly. Saver status. Yeah. So that tells you basically that you have less than 20% remaining and the phone is in some kind of energy saving status. But that is nothing that's available in the battery status API. So I guess that's not really relevant to us. Let's see. No. So inner JavaScript detect energy saver. Let's see. Battery status API. That's the same thing that we have already. But is there some kind of way to detect if we need to save energy? I already see it. Yeah, it seems like an issue related to this. Yes, power save mode on Android and prefers to use data. But it's about data, not really battery. So nope. Okay. I guess that's not really key for now. So let's start with the things that we can implement. So we will just disable this one on WebAssembly. So remaining charge percent, that's something we can implement. Power supply status is definitely something we will want to implement. These are the events which are actually implemented incorrectly now because we have a better way to do it. So that's something I will improve. Battery status is what we have, but let's check. Not present, discharging, idle, charging. Okay, so let's start improving the API a little bit because we have these existing classes, but they are not correctly documented, so I will do that now. Plus, clean it up a little bit. So let's use the official docs to improve our docs. Actually here. This is pretty nice because we can actually reuse Microsoft's documentation from UWP to improve our own documentation in code. So basically the same docs from Microsoft's docs apply to our code as well. Oops. Right. It's better status, energy saver status. Like, even though these enums are not available on, like the usage of these enums is not available on all platforms, we still have them as implemented on all platforms, because that will save you from having to write if check for WebAssembly, Android or iOS and so on. So this will be more pleasant for the user. But still, if you want to use Power Manager, you will see that that's implemented only on those free platforms that support it, not on the others. So that really makes sense to the developer. Okay, so power supply status. Okay, that's this one. Now, we probably will not be able to detect if the power supply is adequate or inadequate, but we'll just assume adequate when the device is charging, for simplicity's sake. So that we have this part, and now let's start with the Power Manager itself. So Power Manager definitely needs some docs. Let's make it file scope namespace. And now let's see what we need here. So for WebAssembly, we will not have, well, actually, let's keep it for now. And let's actually ditch all of this and use the proper way. So instead of event handlers, we will use something called start stop event wrapper, which is a feature that allows developers to easily implement an event that has to be started and ended, and only when it's actually subscribed to, it will perform some specific functionality. Oh, sorry. I was not checking. I'm not really building anything blockchain related, so I will probably not be able to help with that. But yeah, I suppose when you build an mobile application for your project, that's something I would be helpful with. So let's go back to this one. Well, you can find me on Discord, definitely, on the Windows developer Discord. All right, I need to initialize it differently. So let's do upper. This is remaining charge. Oh, let's name it like this. It makes more sense. And battery status. Changed. Okay. Okay, so all these are going to be initialized during the construction of the Power Manager, and I have to check if we have some specific constructors on the side of specific platforms, and it seems we do have them. So in that case, I'm thinking whether we should move the constructor to the main class and then call some platform specific initialization from there, which makes more sense probably. So let's do it like that. So constructor will be here, and we will have some kind of partial initialized platform, which will take care of the platform specific initialization. So but like I can send you the link to UWP Discord, but I'm just saying I'm not really available for any jobs as I have way too many of them. Okay. This is the main Windows Developer Discord page, so you can use that. Oh, I'm not sure if you actually got that. Okay. Discord. This is the link. Okay, so let's get back to this one. So we will initialize the power supply status change, energy saver status change, and so on with the proper methods. So for each of them, we'll have. Okay, why is it not? Oh, it's static. I want it. It has to be static though. It has to be static. So Power Manager itself is fully static as well. Let's see. So it's a static class, which we don't really have here. So let's fix it. Well, that's good to know. Because we had, yeah, it's static constructor, but we didn't really have it marked as static, so there was a unintentional constructor which we have to get rid of. Right, so the new start power supply status and power supply status, and there will be one shared synchronization lock between all of those wrappers. So well, it's called, let's simplify it like this, and start remaining. And start battery status. Not sure how to name it, if it's good to have just this or... Well, for now let's keep it, but doesn't seem too clear, maybe. Okay, so these are... Initialize should be static. Okay, so like this. That's fine. Now each of these will have to be static partial initialized platform. So like this and like this and like... Okay, we don't have initialization here, so that's fine. And okay, that's fine. Actually thinking if macOS does have any power management API as well, maybe that could be implemented later. All right, so get battery status, get power supply status, remaining charge percent. So each of them will have to be implemented. For now we have just the battery status itself. And now let's simplify these. So power manage supply, add handler value, and remove energy status. Okay. This will remove a lot of lines of code, which is always a good thing. All right. And finally, battery status. Add a handler and remove handler. Good. So that's it. And now finally, what about these? So raise remaining charge percent changed. This is just basically raising the events. So and we don't really... Okay, so it's actually getting that value, checking if it's different, and then raising the event. So remaining charge percent changed, event invoke null. The same for this one and this one, and finally this one. But of course we have to make some adjustments. So the energy saver is not implemented on WebAssembly. So we will mark it like this. We will also have to avoid initializing it here. Oh, let's move it to the end so it's more clean as the one single specific one. And finally this one is disabled as well. Let's move it here, and same thing for this one. Make it WebAssembly disabled. And So there's a question. Is there any other initialize method? If not, something, well, like there's no other initialize method, but the reason I'm specific here with the platform is to make it clear that the initialization is platform specific, is on the native side, on the platform specific side. I agree it could be initialize only, but it seems to be more clear in this case that you should find this specific initialization on the platform specific file. So like the here and here. So it's more, so it's clear that it's platform specific initialization, not just some general initialization. So let's go here, just disable this one. And now let's fix these, because we have duplicate definition for all of them, as we didn't comment out those members in the generated class. So this is the one. Is it the one? No, this is something else. There is another power manager in UWP, which is still coming from the Windows Phone side of things, so that's pretty fun. Okay. This is the one. So I see there is gonna be a little hitch with this one, because if we implement Power Manager, or actually it's not gonna be, it's fine. I thought it would be a problem if we implemented it only on WebAssembly, but not in the net standard reference part, but it's gonna be handled just fine without it. So good. We have energy status, that's not implemented, that's fine, but we have power supply status implemented, and we have this one here, so like this, and the same for this one, and the remaining discharge time is not something we can really check for, or is it? Just confused. So yeah, it's actually giving us charging time. So remaining time in seconds until battery is fully charged, which we can actually give the user, or add this discharge time. So there's no remaining charge time, but discharge time is something we can do, which is this one. Okay, this is useful because we can implement one additional property which is not available on the other platforms. So let's mark it as implemented. Let's move it into this file. And make it WebAssembly specific. Or should I keep it here or just put it into WebAssembly file? Well, let's keep it here, because maybe it's gonna be possible to implement it on Android or iOS as well. I just missed it when I first implemented those. So let's keep it here. And there is also an event that's related to it. So this one. So the event is here for battery status. There is one for energy saver, which we cannot implement. There is power supply status, which we are going to implement. There is remaining charge percent. We are gonna implement that, and we're gonna be implementing remaining discharge time as well. Okay, so we'll have to add this one because we don't have it. For it specifically, we will be adding remaining discharge time changed. Or can we actually observe it? That's good to check. Discharging time change, yes, it's there, so it should be completely fine. All right, so only for WebAssembly, we are gonna have this one, and we'll add remaining discharge time changed with new okay, so like this. Okay, that should be all. All right, and now let's implement all of those methods, which there are plenty of. It would be nice to have them partial so that we don't have to implement all of them at once. But doing this will not help because I'm pretty sure it's not gonna help. Or it will. Okay, so you can use a partial method as an action. That's interesting. Well, that's only helpful for us because we can do it like this. So we can predefine all of these at once and just implement them at our leisure. Oh. Oops. And okay, there's quite a few partial methods. Oh, now are you complaining? That's unpleasant. The IDE did not complain at first, but now it's complaining that those methods cannot be partial for it to work. So that's kind of annoying, but we can actually do this. And if done like this, it will actually work properly. So it's a bit more verbose syntax, but still kind of readable. All right. All right, that's it. Now we have all the preparatory work done. We actually can do one more thing. I'll just move all of this to the end of the file because it's just annoying to have it here. And now let's add some documentation for the properties and events so that we have it all nice and clean. So battery status, energy saver status, which is somewhere here. Let's put it inside. Power supply. Remaining charge. And remaining discharge. Now let's actually move this one here. Nice. Now let's implement all of these just to get those values from the Power Manager in WebAssembly, and then we will continue with the events themselves. Those are going to be more complex, so it makes sense to start with the more simple things. Is there some kind of unclosed? Oh, here. All right. I think I did not forget anything, so let's do the implementation here. For each of those, we'll have a separate JavaScript method or TypeScript method that will return the value for the specific feature. Okay. Well, this is the asynchronous industrialization, which is not really something that we want to keep for future. But let's move it into a method for now. It's not going to be awaited for now. Again, it's just a temporary thing, and it's something that we'll have to solve afterwards. But now, let's just keep it simple and call it without awaiting. Not all call returns value. That's because we are not awaiting, but we can actually at least do like this for now. Oh. Why complaining? Oh, it's not async. It's a static thing, so we don't need to have Power Manager. Now lock is enabled. And we'll log it. Okay, so the order is different. It's first the message, then the exception. All right. So let's go back here. I'll keep the initialization in each of the methods for now. Again, it's just temporary. Let's put it to do so you don't forget. And let's invoke the method. So it's going to be power supply status string WebAssembly runtime invoke.js, and we'll invoke it's like this, JS type get power supply status, and we will be parsing that into power supply status value. And here we get some fallback. In this case, I guess it's fair to return not present as the fallback. Okay, let's name this to power supply status. And all of the remaining methods will be very analogous, so I will just copy paste this and rename accordingly, which is the surefire way to make some mistakes, of course. Power supply status and remaining charge percent. Oops. So the remaining charge percent is not an enum, of course, that's an int. So it's an integer percentage. And so it's going to be int parse. And of course, with lowercase r. And the question is, what's the default? They don't really tell us in the docs, but we will be able to see it if we run this on a desktop PC which does not have any battery. So that will tell us if we should return some infinite value or we should return -1 or something like that. So let's keep that as to do. Let's do fallback and remaining charge percent is returned. So that's fine. And now we have the last one, which is what? Remaining discharge time. Get remaining discharge time. It's going to be a time span. And now that's the interesting thing is that we will probably not want to get any time span value from JavaScript. So let's do something like remaining discharge time. And we'll check the documentation here. It's a double. So double, we will get it as double and try to parse it, and then we will make a number of seconds from the double in a timestamp. Oops. In seconds. And we will create time span from it, from seconds, like this, and it should be enough to work with. The question is what to do with the not the number values. We'll have to figure it out as well. So to do, and also the fallback. Again, not sure what to do here, so let's return time span 0 but we'll have to figure it out from UWP. All right, so we have covered the basics, and let's just go back to our sample page. Oh, that's annoying. And let's get our sample page, and we will use that page to add additional test properties there. Yeah, this is the one. Okay, so the sample page is very basic for now. We have just battery status, energy saver status, power supply status, and remaining charge percent. We would like to have also remaining charge time, remaining discharge time. Let's actually improve it completely, because this is a simple page but does not contain any data binding and so on, so it would be a pain to work with. All right, let's do UWP. And let's work on that page a little bit. Right. Was the power manager Zabel? So we will make it use a view model instead of this simple event-based implementation. So let's add a public class, or actually internal class, power manager tests view model. Let's get rid of this nesting because it's unnecessary, and let's adjust this attribute to the modern sample attribute. Name power manager. View model type will be type of power manager tests view model. Okay, so let's get rid of this and move it right here into the constructor of the view model. There is a base that expects a dispatcher. It's not required anymore. That's interesting. Oh, nice. It's not required anymore. All right. And let's move all of this into here. So, why is it complaining so much? It's just confused about everything, so let's do a rebuild. Let me just turn off this thing. Okay, so this failed miserably, clearly. So it's because something is just appears to be missing, but it doesn't make sense. It's not really true because we are just using Windows and it should not be building these parts at all. Oh, UWP. Oh, that's wrong. I see what's the problem. We have the wrong override. We are now using a different version of Windows SDK, and that's this one. Now, that should work. Yeah, it's already much better, so you should be able to use this one now. All right. And let's start improving the whole thing. We'll be able to make that sample much better if we allow the user to manually attach and unattach the events themselves, because currently they are attached immediately after startup of the sample, which demonstrates how they work, but you are not able to see if you are able to actually turn them off and the notifications are stopped then. So let's wait for it to build. Oh, okay, it crashed completely. Okay. So let's divide this page into 2 parts. One will be a set of readings, and the other will be a log of events that are happening. So we will be able to see when events occur, and we'll be able to manually refresh the values above it. There will be some toggle buttons. Get current values will be retrieving the current values for all of those properties. So instead of this, we'll use data binding. Let's get rid of this space, because the space will be created by the space between the runs. Come on. Let's make it use one-way data binding everywhere. It's fine. Will be a button to clear the data log, event log. Let's do it with some spacing and add some default spacing between all of these as well. And that's good. Oh, should be content. And now add some buttons for the events. So okay, so there will be battery status changed, energy saver status changed, power supply status, and remaining charge percent changed, and remaining discharge time changed. So all of these each will have its own toggle, so it's checked. Right, so there's quite a few properties, and we'll have to add them all into the view model. So this should be grid row 1. Okay. It should be quite good. Let's just split the screen a little bit so you can see it side by side. So first add the model. Come on, give it to me. IntelliSense is not behaving well. Oh, it's missing the namespace. Why? I removed it accidentally, maybe. Alright, now it should be fine. Okay. So here we have to set the model. Let's get rid of this. And now let's add all the properties. Of course, we have to make them a full properties, so it's gonna be string battery status, oh, this is wrong. Why do we have twice energy saver status? It's definitely not correct. Is this fine? Yes, we have 5 properties. 5 properties, that's fine. So power private string remaining charge discharge time. There is also remaining charge percent. There is power supply status. So all of these okay, so we have this simple property, and for each of them we'll also need a on property change or raise property changed. Good. Okay, so we have a lot of properties, but we will need even more, because for each of the events we need also one property to be defined. So it's gonna be yeah, let's keep it simple and do it manually. This is nice. It was actually suggesting the proper names. That's cool. Even though it worked only partially. Okay, we have it. Let's encapsulate all of them. Okay. All right, so that's finished. And now let's do, what is this? Ah, it's just internal. Now let's clean this up. We'll have a specific method to retrieve the properties. So private void refresh values. Or get current values. Oh, let's name it refresh. Naming is the hardest thing in computers and software development. Okay, so this is save getter. This is a simple wrapper around retrieving some specific value, and the reason for having this is in some platforms the properties will not be implemented, and in that case they will throw an exception. So that's the reason why we have this in place for safety reasons, basically. Okay. This is integer, right? So let's add %, so it's nicer. And remaining discharge time. That's a time span, so I'm not sure about the formatting of these, so let's just keep the default. We'll see how it looks. Right, so this can go away. So this will refresh our values. We will have to add a property for that command. So interesting factoid is that this will waste memory, or instead of, if you use instead this, it will actually be more memory efficient. It will not create the same lambda every time. It's gonna cache it properly. Which is a weird thing, because you would expect that this would be the one that's more efficient. Right, so that we have this one, and now just the subscription properties. Oh, we have wrong naming here. Ah, we forgot in some places, but did not forget in other places, so that's gonna be annoying to fix, but not that hard though. Now we need to make sure that these properties are updated in a two-way manner. And also we'll need to make sure that we actually subscribe when they are set. So on the setter, well, maybe I can actually make it more usable if we use serial disposable. This is a thing that essentially allows you to dispose things which are when it's set anew. So we can make sure that each time we subscribe only once, because if it was already subscribed, we would be able to clean up the previous subscription. Also, we can add these disposables. We can add disposables to disposables of the page. So that means that when we go away from this page, we'll be able to see all of those. We will be able to automatically unsubscribe all of those subscriptions. So that's pretty nice. And we'll rename those as well, so it's clearer. So battery subscription. So make it like this. Visual Studio is very slow with formatting and cleaning up code, so usually it's much faster to change the code manually instead of wait for the IDE to do it for you, which is kind of sad, but it's the sad reality. Anyways, we made it happen manually, and now what is this? Oh, this is just complaining. Not really important right now. And we will be able to use a different way of checking for the subscription. So disposable, not now. We'll say if there is some subscription already, and we will be subscribing if value, if we want to subscribe, we will do so here. So disposable, create. So UWP, power manager, battery change status, like this. Oh. Well, actually, yeah, we will need that event. And there is one already, so why not use it? Huh? That's fine, I guess. We will actually unsubscribe it on dispose. And we will do, if we are unsubscribing, we will just set battery status change subscription to null. This will unsubscribe for us and make sure that we don't have 2 subscriptions in any time. Alright, so that seems fair. So now let's do it for all of them. Energy status changed. It's like a lot of boilerplate code, but it's just a sample page, so it doesn't really matter to make it. It's not really worth it to make it too readable or too magical, like a reflection based or something, because it's just a sample and it will serve its purpose even without being too clean. So it's a lot of code application, but it doesn't really hurt in this case. So energy saver status changed, disposable, power supply. What is this? Subscription. Ah, we have everywhere subscription. That's ugly. Subscription. Better. Okay. So we have this. We have power supply status. Status. Oops. Okay. Good. Let's do the same for remaining charge percent. Power supply status. Good. And the final one is discharge time. Remaining charge percent. Remaining discharge time. And capital. And we are done here. Okay. Finally, let's fix those event handlers, because we want to make it a little bit better by outputting into that event log that we created here. So we will have a observable collection. Event log, and we'll add events to that collection as they come into our device. So we will create a method that will log an event. Event name, and it will do its magic here. So it will add a line with current time, So let's do it like this. So it will be date time now, and let's make it let's use some nice format, so too short time string is enough. And then the name of the event. All right. Which MVVM framework I'm using? In this case, this is just a sample application in Uno platform, and it's using its own custom MVVM facilities. So it's just like a few MVVM based classes defined in this sample app, because we don't really need full MVVM here. It's all about sample pages that are being run and checked either by UI tests or runtime tests. So this is just a facility to be able to do data binding in the application, but it doesn't have to be like full-fledged MVVM framework. Also, it's helpful because we are actually be able to test the features themselves, not being like dragged down by some potential bugs in a MVVM framework. So we're just using what we actually need, not what would a full MVVM framework offer. So that's it. All right. Let's go here. So we also need to define the command that will clear the log. And that's it, I guess. Now let's update the event handlers so that they log the event. So it's gonna be very simply, let's actually move this here. Oh, this is gonna be async void, but again, it's just simple page, so it's not gonna hurt. What is it complaining about? Dispatcher. Dispatcher? Why is it complaining about dispatcher? Why do we don't have dispatcher here? Oh, right. We have to actually get it from something. View model base, there should be, there is a dispatcher property, so I'm not sure why it's complaining. Oh, it's actually wrong braces. Ah, good. This is synchronous, and we can actually log it. And now let's do refresh. So on each of those events, we will also refresh values so that we always see the most recent ones and don't have to click manually. So log event, and it's gonna be battery status changed. Plus keep the naming correctly. Or you can do actually like this. Charge percent changed. power supply status changed, and there should be one more. Yeah, let's get rid of the async. Like, I used async void there. I know about that, but it's just about writing to UI thread, so I guess that's not gonna be problematic. And it's, again, it's just a sample page, so. Purely for manual testing. And we don't have remaining discharge time changed. All right, that's it. Let's make these more succinct. Document. Yes. Better. Although this is kind of messy. Nicer. And this is a long line. Okay, we're all done here, I guess. So let's see it in action on Windows, because that's the way to start. What is missing here? Oh, this should be working. Or is it not working? Ah, it's working now. It's just failing. Yeah, just timing out. Oh, okay. Base here. Come on, where is it? Should be built by now. Okay, this is starting to be quite weird. This should be already running. Huh, that's not the one. Oh, let's try again. Come on. Ah, finally. Finally. Okay, I can prove this one. Okay, so let's see. We have Windows System, Power Manager. Okay, what's happening here? What's happening? Whoa. Constructor not found. So the constructor is not officially required, but it is required. Seems. Okay. So this thing is actually creating the view model, but it requires this constructor to be there. Can we actually check get constructors? if there is a parameterless constructor, we will use, or if there is one which contains a dispatcher as a parameter, we will use that, or we will just use the parameterless one. So let's do it like this. All right. Oh, nice. Let's get, and can actually merge this one. Hopefully. Ready to merge. If it finishes. Come on. Come on, come on, come on. That's fine. Let's go back to this one for now. So we have the power manager, something better. Power manager API, and we have, okay, so all right, so the thing is that we have this. These values are for a PC, so these are the fallback values because we don't have any battery in a PC. Well, there is a battery, but not in the traditional sense of the word. Let's just improve this a little bit by adding padding. Much better now. Anyways, so we have energy saver disabled. Let's see if we can actually enable energy saver, because that could be possible. It is not possible. Well, doesn't really matter. So these are the default values in case it's not available. So we can fall back to them. Battery status is not present. Adequate is the power supply status. Well, it's connected to the power supply, so it makes sense. Remaining charge percent is 100% if we don't know what to do. So let's actually remember that. And what is this? I am not really sure. It's probably time span max value. Let's go to this. And let's see what the value is. So it's basically the maximum ticks. So it's the max time span value. All right, so makes sense. We can do this. So let's stop it. We have a fully functional, hopefully. We didn't test the events, but we'll see. It's gonna work at least on Android and iOS. And let's actually test it on Android, because that's gonna be a way to verify the sample works. So let's put this and this and this as improved. Oh, let's do it like this first. Now, and now for this. So we will probably not push this right now, and I will switch to Android so that we can see if, well, adjust the code so it compiles, and then we will see if it works or not. This thing does not start up, so I will just force it. That's odd. All right, it's starting now. Okay, let's go to here, change the target to Android, and let's run it on Android now. Let's go immediately to Power Manager Android, because we'll have quite a few things to fix there. Can get rid of this. All right, so This is fine. It will actually complain once it loads properly. Come on, what are you doing? How can applying file header preferences take so long? Especially when there is no file header preferences. That it's mind-boggling. Right, so we have. Is it loaded already, or it's just still loading? It's still loading the syntax highlighting. Ah, finally, we are here. Okay, so remaining charge percent. Good question is if we can actually get remaining charge time from Android. So let's see. Well, doesn't seem like there is a way to do it. There's a lot of interesting ones like voltage and temperature and so on, but there is no property for remaining time for discharge, so we will probably not be able to implement this one. But there has to be a way, because if it's implemented on the web, Android should be able to give that value to the site. Well, maybe in the future. Alright, for now, let's fix this, because we have a lot of these partial methods that we changed and we don't have them implemented, so the name should be like this, and it should be partial. Let's fix it everywhere. All of these methods will have to be partial. Okay. This is fine. There we have this. But multiple places actually register this, right? Or is it just this one? Battery status and remaining charge percent require this one. So we shouldn't really... okay. So the original implementation was buggy because we did not check if we actually want to register these. So we have to be mindful about whether they should really be registered or unregistered. Try unregister. Try unregister. And all right. So the registration happens only if it's not already registered. So it should be like this, actually. That makes sense. And same for this one. Oh, I just broke something. Come on. All right. Try. So we should wrap this whole thing into the try, because if we are already registered, we should not re-register those receivers. And in case of unregistration, we need to make sure that we unregister if both are actually cleaned up. So like this, we need to check if someone is registered. Okay. And that's better now. Okay, so we have this covered, and what is this? Why do we have it like this? It should be this way. And this is fine, this is fine. It seems like we fixed what we had to fix. And now we can verify if it really worked. Although maybe this will need to be changed. No, it's working. This is working. And this is working. Okay. Let's run the application on the phone now. Oh no. What have I done? I'll run it on my phone, and we will be able to see what happens if I connect and disconnect my charger. I will run it without, let's run it with debugging for now, but I will be disconnecting the phone during the usage, so it's gonna then crash. Come on. All right. So the build is running, and we can go back to reviewing PRs. Okay. Let's take something older. I have to check that. Let's check this one, for example. There's a failure, but this one does not make sense. Ready to merge. Let's rerun this. It's mainly sample pages. It should be fine. Okay. That's probably fine then. It's okay. Okay. What do we have here? Oh, okay. Our application is now running. Okay, let's show the screen. Okay. Good. So we have the application running and you should be able to see, let's move it here. Should be able to see the system power manager. Okay, so battery status is charging, that's fine. Energy saver is off, that's correct. Power supply status adequate, 76%, and we don't have the remaining discharge time. So let's subscribe to all of these. And let's, for example, disconnect the charger. So we should be getting some events, but they are not coming. So that is the first thing that is not working. But potentially that could be a problem of the sample page itself. So you have to be mindful about that. And well, how can we check it easily? Because I cannot disconnect the charger while it's debugging. But what I could do is use the emulator. And in there, I should be able to change the charging percentage manually. Well, let's do that and we'll see how it helps or not. So this is sample pages. That's fine. And what about this? All right then. All right. Nice. It has a runtime test for text block wrapping. That's pretty cool. Oh, it's checking for line count. Nice. This is nice. This syntax is C#9 and newer, but it's very nice and succinct. You can check for multiple enum values at once, so that's pretty cool. So if it's changed, then okay. I don't really see the reason why it's needed to store that value and then restore it. We'll see what happens, what's the answer, but apart from that, it's a nice PR. Okay, emulator is starting up. Oh, right, I have disabled Hyper-V temporarily and forgot to re-enable it. Well, let's try to see how bad the performance will be without Hyper-V. I'm afraid it's gonna be very bad. Anyways, so let's investigate why our functionality was not working, if we can decipher it from here. So if you subscribe to power supply status changed, this is fine, it's subscribing the right ones. Although we don't have remaining charge time changed yet, so that we'll have to add for WebAssembly. But I don't really see the reason why it shouldn't allow us to see. Okay, so the emulator allows you to change the charge level and the connection of charge and so on. So that's very good. We will be able to see it live in action on the emulator. But for now, let's go back to reviewing PRs. Something nice. This one. If it's ready to merge, then remove this. Let's see. Okay. So our tests, pretty straightforward, probably from MUX, math token, nice. So properties, just a cleanup. Okay. Interesting, so the default is not a number. I didn't know that. If value is not a number, or the new listed value is not a number, so if either is a number, oh nice. Our very slow emulator is running. Oh, this is really painful. Well, it's very slow, but we can probably use it. As long as it does start up, because so far it's stuck here. Well, we'll see. All right. Okay, will it start or will it not? That is the question. Far it's not moving from this place and it's deploying, so I guess it's not working. Let's see once more. Okay. Another build operation is running. That's not really true. Uh-huh. It's completely failing now. Let's run it again. We'll see if that helps, but if not, not sure what we're gonna do, because I need to know how, if the events are working, and the only way to know is to be able to actually test it, but not on the desktop and not on the phone. It was actually a way to debug Android applications remotely. Okay, like this, but like this. Uh-huh. Let's kill this one. Right, my phone should be now connected. Ah. Okay, let's try this one. No big deal. We'll find out manually and So which one is it? VLAN, that's the one. Okay, it seems we are connected, but I don't see it yet. I don't see it yet. Let's try restarting. Maybe it's gonna pick it up. Come on. Let's hope it works. So, where is my phone? Oh no. It's just refusing to show it to me. If this will not work automatically, it should be nice. But no, it doesn't seem so. Deploy failed. Although the problem might be actually that some of those Xamarin things have failed completely. I'm not really able to run it. Why is that? But there is no emulator showing up either, so it's very weird. Something is broken. Something is broken here. I'm not sure what that is. Project is not deployable. What does it mean? Not deployable. Huh. I don't like how that sounds, you know? Not deployable is not good, usually. See if I can enable it this way. Developer settings. settings. Oh, wireless debugging. Nice. Will that help? Not particularly. Okay, what if I cancel this? Restart. Okay, we'll see if Visual Studio this time does work. Now we just completely lost the list of emulators as well as the device, which is mind-boggling. Not even connecting directly now helps, so it seems we just broken the whole infrastructure. This is so sad. We'll not be able to build anymore and deploy to the phone, so this means our attempts on Android now are basically over. Well, this took a little bit longer than I expected, but at least we have now a functional demo page which we can use. I'm not sure if we can simply. Well, let's implement at least one thing, and that's the basic properties on WebAssembly, because that will give us at least something we can check, and we can then work on that event log next time. So I'll switch back to WebAssembly and work on that part first. All right, so we have the sample page. Let's go to WebAssembly and let's now fix the defaults. So we know that the remaining discharge time, if not available, should be max value. Is that? Or what is the name of the, what is the proper naming? Remaining charge percent, it defaults to 100%. So that's resolved. We have this, okay, max value is correct, so that's resolved. Okay, if remaining, if not, oh, and okay, let's do it like this. Not double is none. Remaining discharge time in seconds. Then return the value, otherwise we just default to max value all the time. The same thing here, so we just parse it, that's all good. We can actually make it more succinct like this. present. The same thing here. Oh. Right. And finally, here, can we simplify this? Yeah, we can do that. Well, this is more readable, I think, because these were two conditions, so it would be just way too much code on one single line. But this can be simplified like this. 100, and we are done. Good. All right, so that's for the properties. We don't have the events implemented, but we can start with this at least. Although, yeah, that's fine. I will just add that event for charge time, discharge time. So if WebAssembly, then remaining discharge time changed. So that's it. Remaining discharge time changed and removed. And finally, we'll add the method to invoke it. So here, and let's clean up. So this is only for WebAssembly, and this is only for non-WebAssembly. So we are done in here. And finally, to actually be able to see anything live, we need to implement those TypeScript methods. So we have battery status, but we need power supply status and the other ones. So it should be this one. So get power supply status. And there we have. All right, we don't have any properties for that here yet. So let's add those. So power supply status. What is power supply status? That's just notification if the power supply is connected. So we can basically use the same approach. We can see if it's charging or not. So if it's charging, then let's return adequate. And if not, then not present. All right. Then we have charging time, we don't have that. Discharging time and level. So let's do, what's the name of that? Get remaining charge percent. Here. So remaining charge percent is the level property. So it's gonna be level as a number. We'll return a number. And we just return the number itself. And if it's not present, we will return, well, what do we return? Not a number? We could do, but maybe we just return the 100 that we saw before. The level is a number from 0 to 1. So we rather need to return this. Well, should we do that in C# or in here? I would say we will just return this and then do the conversion here, because it makes more sense. The remaining charge, and we actually need this check here. So let's return the if. We'll return 100 as default, and now we will convert to percentage. So and like this. It should give us the integer value of that remaining charge. So that's done. What's left? The remaining discharge time. That should be in seconds, if I'm not mistaken. Discharging time change. Okay. So here we have discharging time, and it should be a number. Yes. Discharging time. And if it's not available, then we return max values. So how do we mark it as number? Well, let's do it like this. So if number is none, or yeah, let's do it like this. If number is finite, discharging time, we will return discharging time, and otherwise we will just fall back to -1. And with -1, we will use -1 as the fallback. So here if it's greater than 0, greater or equal, then we will return the proper seconds, otherwise max value as the fallback. Okay, that should be it. Now, we should be able to build this, I guess. Although we need to actually run it on the phone, so I will install one additional thing. That's this. This is a nice extension that will allow me to run the site on my phone, which is normally not possible because it's protected by firewall, and the IIS Express will not serve to other IPs than the local host. But this nice tool works around this issue. Okay. So let's see what we did. Anyway, in the meantime, let's fix this. So we made some refactoring. Alright, so conveyor is running and we should be able to use it now for our purpose. So let's see. Let's do some review in between, so we save time. Well, actually, we can create that PR as a draft, at least so I don't forget about it. Where is it? Ah, here. Okay. Let's mark it as not done, and so we don't forget. All right, the build is almost finished. That's good. JavaScript is updated. That seems promising, and this should be any moment now. What is this one? Isn't it ready? Come on, download. Okay. All right, here we go. We'll open it on my phone as well. Okay. Oh, HTTPS. Oh, it's fine. It's running. All right. Oh, it crashed. Oh, not a big deal. We do have it running on the phone, so we should be fine. So system, power manager. Okay, so we have the battery status is discharging, power supply is not present, remaining charge percent is 79, which is matching what we see on the phone. What about if I connect? The remaining discharge time is kind of weird because it seems like in 4 seconds I will be out of charge. That does not really sound correct, but let's see what happens if I connect the charger and refresh. So it's charging, power supply status is adequate, remaining charge percent is 79, which makes sense. Still true, and remaining discharge time is now max value of time span. But what about the discharge time here? This does not really sound correct. Maybe it's the problem of the API itself, but let's verify we did not miss anything. Remaining time in seconds until the system's battery is completely discharged. Well, we did return the value in seconds. Discharging time. So I don't really see a problem with this. Remaining discharge time. And here we have remaining discharge time. We parse it from double. We get it if it's, we check if it's in seconds, and then if it's more than 0, then we convert it from seconds. Doesn't seem problematic to me, and it's quite possible that that Android does not return the proper value correctly, and that could be actually the case. Anyway, we can run it on the PC as well, even though it's not really useful, but just to verify that the default values work as well. Yeah, it seems that every time the discharge time is just 4 seconds. So they should probably fix this. Power manager, refresh. So charging adequate. Yes, because this is a PC, so it's always charging 100%, not its max value, adequate supply status. Yeah, seems good, seems good. All right, so we have covered the basics. Now what about these events? let's first try to make them occur on Windows. So here we have, oh, I needed Windows. But actually we can simulate it. We can simulate it manually. That's gonna be also just enough. So let's keep WebAssembly. And let's open WebAssembly. And what we can do is just implement those events, and then we will actually observe what happens if we trigger them, and we can log those values to see if triggering actually works. Okay, so let's go back to WebAssembly here. And we'll create a set of dispatching methods. So these methods have to be public and static. And will actually notify us that something happened in JavaScript. Well, that the relevant event has been triggered in JavaScript. Oh, come on. IntelliSense is just so slow most of the time. I will just steal that from something else. So like here, no, not here, but sensors, accelerometer, WebAssembly, public static. So it's in Uno namespace. Okay. No, still that. Okay. We'll just raise battery status changed and so on. Yeah, because we need to return. So return 0, and let's do the same thing for all of them. So dispatch battery status, dispatch power supply and battery status are essentially the same property for us. So we don't really need a separate event for that. So it's a charging changed is the same thing as. So let's make it like this. So charging changed, and charging So we can simplify the code a little bit. So we know that supply status and battery status both are based on the same property, but in this case the default is different. So yeah, we will probably not make them the same, but at least for this one. So in case of charging changed, we will always raise battery status change and power supply status changed. So these both will be always triggered at the same time, and the rest will be remaining charge and percent changed and remaining discharge time. Oops. All right. So we do have these. We need to make sure that these methods are not linked out by the linker, which we can do quite easily inside of Uno UI. So here we have linker definition WebAssembly. So we will have to add those here. Is it the right one? No, it's not the right one. Here we have to add it in here, for example. So the name of the namespace is Windows System Power Manager, and the names of the methods are dispatch remaining. Oh, come on, where is it? Here. Here, dispatch remaining charge time, charge percent, and no, dispatch charging. So that's it. And now we need to call these methods at appropriate times, which means that, oh, this is not correct spacing, but whatever. It means that we will have to add those here. So we'll need to add some event handlers here. So these are just event handler and oh, so how do you do event handlers in TypeScript? I don't really know. How do you do that? Huh. Okay. So that is... All right, that's the event. Oh, we don't have to declare it? Maybe we can just do something like this. Oh, no. Let me check one again. So we could like subscribe with this directly. Let me check how they do it. So event handler. So power manager, battery. So event source. Yeah. This is the lack of knowledge about TypeScript that's problematic here. Add event. Oh, nice. We can steal this. So it's gonna be this. Oh, that's fine. And the name of the method of the events are charging time change. Oh, well, discharging time change and level change. That's the problem with being on the bleeding edge, as the type definitions for the battery manager are not yet done by anyone else, so that makes it more complicated. Anyways, so we add the event listener for charging change. On charging change. We actually can do it same way like this. I will steal this. Put it, power manager, put it here. So on charging change, we need to have the dispatch method separately. So charging change, dispatch charging changed. System power manager dispatch charging changed. And now we need to declare it as well. So let's steal it also like this. I'll beat 3 of those. Dispatch charging changed, the remaining change percent changed, and remaining discharge time changed. All right. So we have all of these declared. We have a method that will be calling them. Dispatch charging changed. And the same for the rest of them. So on remaining, oh no, let's discharging time change. Power manager. Discharging time change. And on level change. So let's create these two. On level change, or discharging time change. These have to be changed to this. and this one to this. Remaining time charge percent changed. Boom. Dispatch, remaining discharge, charge percent, and dispatch, discharging, time changed. This is wrong probably. Remaining discharge time. Remaining discharge time, remaining charge time, charge percent, and charging changed. That's okay. All right. We seem to be done here. So this probably scribe only when necessary. So this is a to do next time, but for now let's try this in the browser, and that will give us some idea on how it works. Or not. I actually remember now. That's the reason why the sample didn't work. Such a simple mistake, but very important one. We unsubscribe but never subscribe. So, okay, that explains many things. So this simple line has broken down our sample. Saver. And here. Wow, that's gonna be much better. Okay. Now we should have actual values coming in the list of events, so that's gonna be very nice. Plus let's make the spacing between lines smaller so that we actually see something useful there. Let's make it like this, and yeah, that should be fine. Okay, let's build it. Okay, let's go back to PR reviews so that we save some time. So what could be nice? Whatever. What about this one? This seems like it's done. This is nice. It's adding WPF runtime tests as well. That's pretty cool. Nice. Let's just verify this. Why does it need to be a separate project? Huh. Oh. Okay, so our build is complete now. This always fails, but that's not a big deal. Should be able to load this anyway and see the updated sources, just verify if it's there. So in here, system, power manager. Let's see if we have some errors. No. This is unrelated. We get the proper values. Yeah, this is not implemented. This is okay, but how can I simulate? Simulate performance. Not here. We can simulate network. That's clear, but I'm not sure if we can simulate battery as well. Probably not. Well, it's fine. It's fine. We can run it on the phone and see what happens there. Okay, I have it here. System, power manager, refresh values on both sides. So we have 74%. And let's do all of these events and see what happens if I connect the charger. Oh, nice, nice. So we got the notification that battery status changed, and then remaining charge percent change, battery status, power supply status. Well, the events just keep coming, and the reason is that, yeah, the battery status is changing, power supply status is changing for some reason. Let's clear it. How long will it take to add new ones? Nothing coming. Let's discharge. Okay, so disconnecting the power supply has changed three. It's called three events: battery status, supply status, and remaining charge percent. And we are now getting those values correctly each time it's changing. So if I quickly connect, I should get, well, it's multiple times for some reason, but the end result is that we get the proper values when I connect and disconnect the charger. You see, discharging not present, and now it's going to be charging adequate. So for some reason, when you connect the charger, it will for a little bit switch to a different status. So it's not going to be charging immediately. It's going to be charging, discharging, and charging. But it's probably implementation issue of the API itself. What if I do? Okay, maybe that's the reason, because I was connecting to a PC. Now I'm connecting directly to power supply. Yeah, if it's directly to power supply, it's just one set of events. Okay then, that seems good. So we have a fully functional implementation of that API on WebAssembly now, which is pretty nice. So I will probably wrap it up here for today, but for next time we still have a lot of to-dos here to fix up, especially the asynchronous initialization, which will need to happen somehow. Plus we will need to fix iOS, which we broke by our changes today. So those are two things to fix. Plus also rerun the Android version to see if it actually works after our adjustments. But apart from that, it's looking pretty nice and promising. So I will, at least for now, push these changes and call it feed Power Manager on WebAssembly. Oh, awesome. Support for Power Manager on WASM. And that's it. Let's push it. And push, and let's see if it's there. Okay. Yep. Good. So that's it for today. Thank you for joining, and we'll see each other hopefully soon in a more regular basis, because now it was like a month without any live coding. I hope to do it more regularly, but I just couldn't find the proper rhythm to make it more regularly scheduled. So hopefully it's gonna happen, and we'll have more live coding sessions with UNO platform or other non-UNO platform technologies as well. So I would like to do also UWP and WinUI related ones. So lots of fun stuff is gonna happen hopefully soon. So stay tuned for that and have a great day. Bye bye.